problems can be very tricky and very intimidating. And so we're always looking for a strategy to help students become successful with those. And so if you are a student, if you are a parent, if you are anyone who is helping students with math on a regular basis, this video is definitely for you. So a lot of times we teach keywords, right? Keywords help us solve word problems. It's how I was taught when I was younger. Just look for keywords. They tell you what operation to do. So I wrote an example of a few keywords that we commonly see in word problems. Less, fewer, each, shared, in all, and how many more. And so we've attached an operation to them. Somewhere down the road, someone has attached operations to them. And subtract, multiply, divide, add, subtract. And so in our minds, we've got this in our head that every time I see the word less or less than, I subtract, or fewer, I subtract, or anytime I see the word each, I'm going to multiply, or in all, I've got to add. So we've become so conditioned to believe these things that it's hard to separate that when we are looking at more complex word problems. And so I cannot teach keywords in isolation. Like, that is not the strategy I teach my students on how to figure out a word problem, because there is no shortcut to figuring out a word problem. I have to read the word problem. I have to identify the question. I have to use context clues and all of the information, the given information, even words. I have to use all of it together as a whole to help me determine what operation I'm performing. I cannot just rely on keywords alone, because it will trip me up at some point. If it's one sentence in a low complexity word problem, then maybe not. I know a lot of times in lower primary grades, it's just maybe one sentence. But once we get into those multi-step word problems, I can't rely on keywords anymore. Keywords do not help me anymore. So the perfect example was the other day, we had a spiral review on the word fewer. And so the question was, David had $5.85. He had $1.47 fewer than Phoebe. How much money does Phoebe have? Well, several students had the correct answer, and then there were several students who had the incorrect answer. And so I asked some of the students, how did you get your answer? And they said, oh, I subtracted. And I said, okay, what made you choose subtraction? And they said, well, I looked at the word fewer and it told me to subtract. And so then we had another conversation about keywords. So I spend a lot of time talking to my students that keywords are not the way to help you solve a word problem. I know word problems can be intimidating, so I cannot just pick a few words out and say, yep, that's my operation, when I haven't looked at the entire question or looked at the entire information. So another example is in all. A lot of times we think we're going to add. Well, if it says Miss Bartlett has 7 cartons of eggs and there are 12 eggs in each carton, how many eggs does she have in all? I wouldn't want to add 7 and 12. I would want to multiply 7 and 12 to get 84 eggs in all. So it's just very important that we do not teach keywords in isolation. The words can help us, but the words combined with everything else in the problem will help us better solve these word problems. And so I like to look at context clues. So that's one thing I wanted to discuss. The other thing I want to discuss is 2 math myths that I see usually every year in 5th grade math, because in 5th grade we debunk both myths. The first one we debunk in like the first week and a half, 2 weeks of school, when we talk about the place value system and multiplying by powers of 10 and by decimals and by 10 and 1/10. And so the first myth is, when you multiply, the products get larger. Well, that is absolutely true in some cases. 7 times 4, the product is 28, the product is larger. 12 times 12 is 144, the product is larger. 14 times 7, the product is larger. 25 times 7, the product is larger. But what if it is 1/2 times 1/2? The product is not larger. 1/2 times 1/2 is 1/4. So if we look here, equals 1/4. Put it in context of a story, I have 1/2 of a cake at my table. I eat half of that. So I've eaten a half of a cake. Therefore, I've eaten 1/4 of a cake. So I have to look at what's happening in the context. This did not get larger, it actually became smaller. So I need to be careful with making this generalization that when you multiply, the products get larger. That is true sometimes. There is a whole standard in fifth grade dedicated to multiplying fractions when it talks about factors determining the size of the products. And that's our scaling factor, or sorry, our scaling standard, which is 5.NFB6, I believe, if you want to look more into that standard. And that tells us the factors will tell us the size of the product. Another example is what we talked about in the first couple of weeks of school is when we're multiplying or dividing by 10 or 1/10. So 5 times a tenth. So we've talked about how when numbers get larger, when we're multiplying by 10 or 100, digits move left. But when we are dividing by 10 or 100, the numbers move right. Then we talked about what happens when we multiply by 1/10. We discovered using base 10s that we're actually dividing. So 5 divided by 1/10 is actually 5/10, which that means this product is smaller than 5. So the product did not get larger. So that's just one myth that we debunk in fifth grade and that I see a lot of. The other myth is the bigger number goes first in a division equation. That is true sometimes. Sometimes that's not true. We first debunked this myth in our fraction as division standard, 5.NFB3, where we determined that fractions can be interpreted as division. Perfect example is 5 cakes being shared with 7 people. How much cake does everybody receive? Well, the total, we have 5 cakes being shared with 7 people equals 5/7. The smaller number came first. So that is contrary to what we are used to believing, that the bigger number goes first. The total went first. 5 total cakes are being shared with 7 people. Everyone gets 5/7 of a cake. So we in fifth grade debunked both of these myths. So I cannot make generalizations about these two statements. I have to be very specific in how I talk about them. The total will go first. And it all, again, goes back to context of word problems and looking at what do we know about size of factors and size of products. And so I just wanted to take a few minutes to talk about the keywords and math myths. And if there are any more, I will make more videos about it. Thank you for hopping on.